And in just a moment, I'm going to show you a change in the schedule.
Okay.
So, yeah, and it'll have the plan for tonight. I just thought I'd share this humor with you first. Um, First slide tonight. Look at this amazing weather forecasting stone sitting outside of this, I don't know, this building. I don't know if it's a or what. Anyway, isn't it amazing that when the stone is wet, it could be that it's raining. Anyway, I love when you get down toward the bottom, the stone jumping up and down, earthquake, and stone gone, tornado. I just thought that was anyway. I just thought I'd share a little humor with you.
That's
You
funny.
get my statement up on top. Who knew a stone could be such accurate weather forecaster? Yes, I do have a strange sense of humor. Okay. Now, Brittany, like I said, um, here's I've been thinking it over, and we're not gonna have a test this coming Thursday, like I told you.
Okay,
So
so we're
here's
putting it in our binders then.
so the binders won't be due not this Thursday, but the following Thursday.
Okay.
Everything is moved back 1 week. Okay.
Okay.
So tonight, this is what we're doing. We're going to take questions like I was doing there with Cindy. Questions on the lesson we just had, 3.6. And I'm going to teach you one lesson 3.7. And then when we come to Thursday, which, this week Thursday, which I'm calling next Thursday, I don't know how you'd say that. It's the Thursday that's July 7th.
Next week. This week.
Yeah, right. What I mean, you got the same problem I do. Anyway, let's put it in here.
It's Sunday. It's already this week.
There. Now there's no question. Next Thursday, July 7th, I am going to give you my presentation for Chapter 7, and the rest of the night we will be reviewing.
So the presentation you're doing, will that be on the test as well? What is it you're presenting then?
Yeah, just remember in the first chapter I did that when I gave the presentation on the two infinities?
Uh-huh.
And do you remember how I told you I might ask you something about it on the test?
Yeah.
And I did.
Okay, so is this also based on Chapter 3?
This is going to be the same kind of a thing.
Okay.
Does that make sense?
Yes, thank you.
You're welcome. So anyway, what I said was going to happen this week will then happen on July 14th, the following week. That's when we'll have our test, and that's when the notebooks will be due.
Okay.
And of course, and that's also the night then if you're doing any extra credit that you need to have it done by.
Yeah. Okay.
Okay, so everybody's got that.
Are we
Now,
doing another chapter after this one?
Say that?
Are we doing another chapter after that test?
We're going to start one. Yes.
Is that information going to be on the final? Because that'll be like 2 weeks after the test then.
Yeah, but I won't. I mean, it's almost certain we will not finish it, but that's fine. I'll just test you on whatever part we had.
Okay.
Okay.
Sounds good to me.
Yeah, originally I thought we could complete 3 chapters, but well, I'm trying to be. What I'm trying to be is understanding the way the schedule has worked out for various reasons. And just the way things fit together. And tonight, I mean, I thought it over, and it's just too soon to have the test this week. So we need a really important part of this coming Thursday night's class is going to be, well, the presentation, but the review. We will. I want to rehash question, anything we can get ready. Okay. So here was the assignment. I left you with for the last lesson. And like I was doing with Cindy, any kind of questions we can go through to help us understand. Now, let me just make this comment. When you get to number 29, that's after the chain reaction problems. When you get to number 29, we never actually talk about that. We never did one, but so those we should definitely do one or two of those tonight. I mean, yeah, as part of our questions. So, but let's start earlier. How about any questions on numbers 1 through 21? So the ones where you had to make the truth tables.
Could we do number 9?
Absolutely. Okay, I'm going to have to make a slide for that, so we'll do that right now. Okay, taking off the keyboard so I can write.
I'm going to get some water real quick, Ron.
Okay, get some for me too.
I know, right?
Okay, number 9. If you have the time, then we've got the beer. We could symbolize that this way, correct? Who asked me about number 9?
I did, but maybe I'm looking at the wrong one. My number 9 says no drinkers are healthy, no joggers drink. No joggers are healthy. Am I on the wrong page?
That'd be page 164, right?
164 says if you have time, we got beer.
Oh, I was on 151.
Wrong one. We need 3.6.
I was doing 3.5.
Well, if you have
Okay.
a question on it, we could, or no? No.
As long as we're on 3.6, let's go with that first, okay? I will, but I'll promise you we'll do that one in just in a little while. Okay? All right?
Okay.
Okay. So, as long as we're on page most of us are on page 164, 165. The 1 to 21, did anybody want to look at any of those? That's where you had to make a truth table, like
I totally
this.
got that assignment. I was good with that.
Here's number 3, for example, okay? Just to do a quick review. Number 3, if you study logic, which is labeled S, then math is easy, which is labeled E. So if S, then E, way up there at the top. And then it says mathematics is not easy, so not E. Therefore, hint, 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 conclusion, I should put the 3 little balls here. Therefore, not S. Therefore, you did not study logic. So we're supposed to tell if this is valid or not. So I made a column for each of those statements, the first premise, the second premise, and the conclusion. And then I followed through with a truth table. And then we looked for all the lines where both the premises are true. Here are the 2 premises. If you notice, there are no other rows where those 2 are true. So there's only one this time. And then here's the key. We look at the conclusion. There is a 1 this time. It's true, so we're valid. So anyway, did anybody have a question on any of those?
Can we do, oh, sorry, it's not that one.
Well, that's okay. Go ahead.
Can we
Which
do
one?
21?
Yeah, let's look at 20.
Those ones I got kind of lost on, so just so I can kind of get an idea.
Okay, so first of all, this is just a copy of what's book up here at the top. Right?
Yes.
Okay. So we're supposed to tell, is that valid or not? So this is like premise 1. This is premise 2. and this is the conclusion.
Yeah.
So we need a column for each of those. I guess if there's bad news, it's that there are 3 letters. P, Q, R. So that means we need the 8 rows. Okay, so then I did my typical setup over here. You know, half and half, 4 trues, 4 false. Next column, I went by 2s, T, T, F, F. And then I went by 1s with R. So are you good with that?
Yeah, those I understand.
All right.
How to get
Now
the
this part is optional. You can either do your knots over on the right or here. Here I just decided we're going to need a knot R and a knot P, so I thought I'd throw them in the beginning. It doesn't really matter if you put those there or maybe over here somewhere, okay? But anyway, I'm going to need them. All right, so first premise, if P then Q. So you go through one by one. What? Only false when the first one's, second one's false, like right here. There's one. Here again. First one's true, second one's false. The rest of these are all true. Okay? The P1 column is done. Premise 2, if Q then R. Now you got to look in the right spot over here. I'm going to change to green. So now you're looking at these two. If Q then R. Here we have a false. Here we have a false. The rest are true. Okay, and then the final, the conclusion, if not R, then not P. Now I'm going to make use of, I'll use red this time. Now I'm doing these two guys. Okay?
Mm-hmm.
Same thing, only false when here's the first one. When the first one's true and the second one's false, here's another. And that's it. The rest of them, none of them start with a T and end with an F. Okay. So, you're still okay?
I'm trying to follow along. So, I guess this is where I was getting messed up was when there's the, why can't I think of the word? Premises 1 and 2, like on the right-hand side. So, where you're getting the premise 1 answers is you're comparing P to Q, and it's true because they're both true?
Yes.
Okay.
But, Brittany, and what I figured out today that helped me learn this, because I was struggling too, if whatever's in the conclusion actually determines that you're comparing P1 and P2, and they should both say true, but if in your conclusion there is a false, that would make everything else, like say the bottom 2 were true, 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 like they are, but say that middle one in the conclusion was a F, a false, everything would be then false if you had one false in those true statements.
Oh, in the conclusion, so in the row all the way to the right, if there was an F, even though the first 2 were true, it'd make everything false?
Yep.
All it takes is one false to make it invalid.
Okay, thank you.
So to be valid, in logic, to be valid, it's got to be valid all the time.
So like if you look at number 19, Brittany, the one right before that, did you see that that one was invalid, but yet there were the 3 trues on top of it? And the bottom row, the 4th row, it had true, true, false. It had the false in the conclusion. So
By the way, it's on the screen right now.
Yeah, it just made it invalid.
Okay, thank you.
Yeah, I was having problems with that today too, and then I had to like reread everything and kind of learn it.
Okay, the only thing I didn't get a chance to say is that the last step after doing those 3 columns, this is kind of what Cindy was just saying. You now have to identify all the rows where both the premises are true, or all the premises. In this case, there are only 2. So here we have, what?
Isn't there 4 in this one? Because there's 4 that are... Okay.
Yeah, I'm talking about the first...
Oh, the
first 2 each row. Yeah, there are 4. That's why I drew 4 ugly-looking ovals here. Yeah. So I circled all the rows, and like Cindy said, you notice in all 4 of them, we don't have any false conclusions. So this one is definitely valid.
Okay, it makes sense. Thank you for helping, Cindy.
You're welcome. I struggled with it too. That's why I figured, hey.
Is there anybody else on the 1 to 1 part? Okay, let's go to that. I'm sorry, we're still on 3-6. Let's go to the 23 through 27 part. The chain reactions. Did anybody want to ask about? I know with Cindy we went through 25 and 27, but not everybody may have been in on that. No,
Yeah,
I don't know.
one of them, or just so we all know.
Which one?
Well, I guess you guys did 25 and 27, so we could do 23.
Yeah, the only problem is 23 is really easy, but let's do it. Let's do it. Okay, here's number 23. This is just a copy here of what's in the book. Whoops. Sometimes this thing reacts strangely. Okay, that's what's in the book. Correct? Oh, no, they didn't have the conclusion. Okay, so let me go back. Here's what's in the book. Right?
Yes.
It says you've got to find the conclusion. Okay, well, did you know what makes this one easy is did you notice that these 2 chain together?
Yes.
Because these 2 link beautifully. You know, if P then Q and if Q then R. Therefore,
You're supposed to have a negated Q.
Well, oh, okay, that's a different thing.
Yeah.
Yep, let's just start over.
Okay.
Sorry.
That's okay. So it's P to Q.
Yeah, I got it here.
Not Q or R.
I got it right in front of me, written in English. If P, Q, and then this one says not Q or R, and you're supposed to find the conclusion. And they gave you a great hint. You see the hint. Now, I gave you that same hint in class last week. I mean last week, but Thursday. Anyway, when you have a not Q or R, that's the same as if Q then R. See, they just plain told you that. So in other words, let's rewrite this. This is the same as if Q then R. That's what the hint says. You can replace. You remember what that equal sign means with the 2 arrows on each end? That means is equivalent to, right? Are you guys?
No, where do you get the equivalent symbol?
This one right here.
Well, I know that one, but it's not in there, right?
It's in the hint.
Are you looking at the hint?
Oh, the hint. Okay, I wasn't looking at the hint.
Okay, all right. I gotta speak more clearly. Anyway, in the hint, do you see how they show that it not Q or R is equivalent to if Q then R? So I can literally replace that not Q or R with its equivalent if Q then R. So now this is what the problem looks like over here on the right.
Okay.
And now, well, now it's simple, isn't it? Because it changes. Do you see how it changes?
Yeah.
If P then Q and if Q then R. So if you start with P, you're going to end up with an R. And that's your conclusion.
Okay. I got it. Well, I guess I wouldn't have figured it out if there wasn't a hint in there. Well, we just kind of now
That's
know.
why they gave. that's why they gave you the hint.
Okay.
We would, although I gave you that same hint, I know you had a lot to absorb, but we did talk about that in class. But anyway, yeah, it was nice of them to put that in there.
Okay.
Okay, so let me just talk briefly about number 27, even though we went.
Can I ask a quick question, Ron?
Yeah.
So, even though they gave us that hint, would that be considered inverse, doing the inverse action?
No.
No.
No. Inverse. Only time we use the word inverse is when you start with an if-then statement, and
Okay.
you want to flip it around, or in this case, leave them in the same order but negate them both. That's the inverse.
Okay.
There's maybe a little similarity, but no, that's not the same thing.
Okay.
In fact, we didn't invert anything. All we did was use that equivalence.
Okay.
Yeah.
I think that's where in the last lesson last week that I missed. I was struggling with, writing them out in a different way, and that's why I don't understand it this week.
Yeah. Well, that would compound. Well, all right. Let's move. Let's take this other part that Cindy and I were talking about, the part where we didn't actually do any examples of, like starting with number 29. Okay. It says you find the conclusion. Okay. Now see if you get my coding here. Number 29 says all politicians run for office. So I wrote that as, if you're a politician, then you run for office.
Mm-hmm.
That's the same as all politicians run, isn't it? If you're a politician, then you run. Okay. And the second statement is, this one's hard. No people who run for office are reliable. It sounds like a ticked off person saying that. You hear that? No persons who are reliable run. No persons who run for office are reliable. In other words, you're saying the whole doggone bunch of politicians is unreliable. And so I wrote that as, if you're reliable, then don't run for office. Wait a second. I got a problem here. I got to come up with. I got to use another letter here. I see. I didn't. My lettering is not real clear. So let me do it. Let me do it over here. If you're a politician, then you run for office. That's good. And I'm going to have to use something else for reliable because I already have R for run. So I'm going to say RE. If you're reliable, then you don't run. Okay. Now, can we do anything with that? Can we chain them? Well, you can't chain them right now, right? These don't agree. Can any of you see what we could do? Remember those tricks we employed in class? Whoops. Put that R back there. So I just copied the first statement. Can't I do the contrapositive of the second statement? You guys know how to do contrapositives.
So it'd be R and then not RE, right?
Excellent. Good. Does that help? Can we change?
Yes.
Yes. And so, therefore, we should be able to draw a conclusion. Can you draw a conclusion from that?
Yeah. If P, then not RE.
Excellent. And there's, So now let's just translate that back into words. So if you're a politician, then you're not reliable. Wow. How true.
This year,
You
that's
know, that's what the argument says. So anyway, if you look in the back, I believe you'll see something to that effect as a conclusion. So what did we have to do? We first had to code this, and that's not super easy.
sorry.
We had to try to see if there was a way to chain them together, and we had to play around. We had to use the contrapositive, and then now we could draw our conclusion. So there's several things that have to be done. Anyway, there's one of them. Let's do one more, and then I'll go back. I'm sorry, I'm doing this backwards. We'll go back and we'll take your question on 3-5 lesson. So
Can we look at 31? Because when we get those short statements, I'm confused by them. Like, some students are intelligent.
yep. Okay. So here, I'm going to, even though it's drawn, I'm going to do it over again underneath, okay? So here's my drawing of some students are intelligent. I'm doing this, I mean, it's a sum, so I don't have an if-then statement. So I'm going to try doing it with an Euler diagram. Would you agree that this shows some students are intelligent?
Mm-hmm.
Mm-hmm.
Okay, the second statement. I'm sorry, what?
At least one.
Yeah, that's what you taught us in class.
Okay, now the second statement in 31 is all intelligent people are snobs. So you can see I already did this up above. So I'm going to say, here's snob 1. Did I draw that right? Are all intelligent people inside the snob circle?
Yeah.
Okay, and yet it could also go like this, couldn't it? Call that snob 2. Is it still true that all eyes are inside of the snob circle?
Mm-hmm.
Yep. So do you get the point that it could be either way?
Yeah, I
No.
forgot. Now I just had a blank moment though, and I forgot how we know when we do the circles. What is the reason? As long as they're both inside, is that it?
Okay. When it says all intelligent people are snobs, all that tells us is that the eye circle is surrounded by the snob circle. But we have no idea how big the snob circle is. As long as it surrounds the eye, it's following what the statement said.
Mm-hmm.
So I'm purposely showing you two different ways it could be true.
Yeah, I remember that part. It's a matter of now determining, I think, whether it's valid or invalid. That's the part I'm forgetting.
Yeah, except this is not determinate. What this one is saying is, can you draw a valid conclusion?
Like, some of the students are snobs?
Yes. Excellent. That is it. Some students are snobs. Because isn't it true? Hang on. Isn't that true with both circles? With both snob circles?
Mm-hmm.
That's why that's the see. You can't say that all students are snobs. Do you see why?
I don't.
Because there's only some. It can go around.
That wouldn't work with snob 1. Take a look. Are all students snobs with snob 1?
There's still some on the outside, Brittany. Remember our circle?
Remember these over here are students that are not snobs with snob 1. Do you see that?
Oh, because it's not in the second one. Or the snob one, sorry.
Yeah, it's not in that SN1. Do you see that?
Okay, now I do, yeah.
So why can't we say all students are snobs? Because it would only be true in one of the two cases.
Gotcha, okay.
Here we go again. When we say a conclusion, it's got to be true all the time. So whenever you're trying to look for validity or conclusions, you can't go with this. Well, yeah, that works sometimes. No, no, it's not. Then it's not valid. It's only valid if it's true every single time. So anyway, Cindy did a nice job of picking something that would be true with both snob circles, and that's your conclusion.
Okay.
Okay, well, all right, now, I'm doing this backwards, and you're going to have to hang on because I don't have the right file loaded. I will do that right now. So you want to look a 3-5 question up. So I got to go back. And I didn't, I should have had this ready, and I don't. Coming. Whoever asked me that question, if you could remind me which problem it is, it'll.
I didn't ask it, but I remember it was question 9 on page 151, 3.5.
Thank you. Question 9.
I think I'm right.
That sounds right.
Yeah, that was the one I had a question about.
Okay, question 9. Here we go. I can get on the right page here in my book. Okay, use Euler diagrams to tell if this diagram is valid or not. Okay, number 9, the first one, no drinkers are healthy. So in black, I drew the drinker circle as separate from the healthy circle. Does that make sense? No drinkers are healthy? Separate.
Yeah, that makes sense.
Okay. Second statement, no joggers drink. So that means when I draw my jogger circle, it has to be separate from the D circle. But as you can see from my drawing, there are at least 2 ways that jogger circle could be drawn so it's outside of the D circle. Do you see that both my J circles are outside of the D circle?
Yeah.
Yeah.
So now look at the conclusion. No joggers are healthy. That would be true if J1 was the only jogger circle, right? Because there's no H there. But it would not be true if we use the J2 circle, would it?
Right.
Do you? Yeah. See, there are some. So because it's not, again, always true, then it is invalid.
I guess I was just confused because in the back of the book they don't do like the J1 and the J2. They just had one of them written, and that was just different than what you taught us in class, so that was throwing me off.
They probably had the J2 circle.
Yeah, just the one that overlaps the H.
Yeah. I prefer the technique of showing them both so you really see what's going on. So yeah, I apologize. Yeah. So I can see where that would throw you off.
Mm-hmm. So just for example, so I know how to do the rest of them, if it didn't say that no drinkers were healthy, J1 would be in the drinking one too, right? Or at least overlapping it, but that's why we set it away from it.
No joggers are healthy is the conclusion that they drew.
I mean, no drinkers are healthy, which is why we put J1 away from the drinking.
No. The reason, okay. Well, the J circles are a result of the second premise in number 9. What's the second premise? No joggers drink. So my only directive was that J has to be outside of D. Well, I did that. Both of them are outside of D. But I purposely, I mean, there's all kinds of ways J could be outside of D, right?
Okay.
And so I purposely showed you that, you know, so if this, so
I get what you're saying. Is
so
it always based on the second premise when you draw those?
usually it's the second premise where everything happens, yes.
Okay.
But I wouldn't say always. It might, sometimes there's more than two premises. There might be three or four. But yeah, toward the end is usually where what? I mean, the first premise, there's only one way. Sure, I could have drawn the D and the H farther apart, but does that really make any difference?
Mm-mm.
No. So yeah, it usually is the later premise where you get this duality.
Okay.
To be honest, I could have drawn a third jogger here, couldn't I? Couldn't I have done this?
Mhm.
And, you know, J3 and J2 both fail because to say no joggers are healthy would be, but, you know, the J1, yeah, that still works, but you got to see those other, you know, we didn't need J3 because we had a failure on J2. So once you come to one failure, you can stop because you know it's not valid then.
Okay.
I don't know, I hope we're getting through. Did somebody say they wanted to see one more of these? I thought somebody made a comment. Could we do another, or am I thinking about something else?
I didn't say anything.
Does anybody want to do another problem on lesson 3.5, which I have up there right now? You know, it's all these crazy circles. I know yeah. I mean, you want to see another one of those. I know we had a whole bunch of them. Especially since the style in the back of the book might be throwing you off.
Yeah, can we do number 27 too?
Yes, we can.
Just while we're on.
So, I'm going to show it to you, but we're going to just do it over, okay? But these are hard to talk about. You can see, I can't, yeah. Let me just start over. And then, I mean, the answer is right, but let's just start over. Okay, so number 27.
Says 1, all math teachers are Celceros.
So, let me think about this a minute. So, if you're a math teacher, oh, I don't know, why did I put this label in the inside? If you're a math teacher, you've got to be a Salcero. Okay, so all math teachers are in the Salcero circle.
Yeah.
All right. Next.
Some math teachers do not sing hip hop.
Yeah, so we've got this not sing hip hop. Wow. I'm going to just use HH for that, okay? Some math teachers do not sing hip hop. So I'm going to, whoops, let me undo that. I got to use a different color. Let's use blue. Okay, I'm going to call that hip hop 1. Did I draw it correctly? Are some of the math teachers outside of the hip hop?
Yes.
Okay. Another way it could be drawn is like this. I'll call that hip hop 2. Again, are some of the math teachers outside of HH2?
Yes.
Yep. That's probably enough right there. Now, look at the conclusion for number 27. Oh, you're supposed to pick which one is correct. Okay, look at conclusion A. Some hip-hop singers are not salseros. Is that true in HH1? Are there any in the HH1 circle that are outside of S?
No. Well, hip hop 2 is.
Yeah, but just take them one at a time. It works with, so, okay. Do you follow? Is it, so is it true for HH1? Are there some hip hop singers that are not salseros? One more time. Are there any in the HH1 circle that are outside of S?
Yeah. Or I'm sorry, no. Sorry, I misunderstood. Sorry, no.
So we have a failure. So we have a failure. So even though you're right, it works with HH2, who cares? We got one that it doesn't work for.
Gotcha. Okay.
So A is no good. So let's take a look at conclusion B now. Some salseros do not sing hip hop. So are there some in the S circle that are outside of the HH circle? Like right here. Isn't that an example of somebody that's in the salsero circle that is clearly outside of both HH circles?
Yes.
So that one's good. So A did not work, B did.
Okay.
Okay, well, at least we had a little bit more practice on those. All right, now, what else do we have for questions? How are we doing on time here? I got to keep my eye on this.
Actually, we only got 15 minutes left.
Yeah, if we only go that far, yeah. Gosh.
I don't have any more questions.
Okay. Well, let's get started on the new. I'm going to put this away. The other one up. Okay. Here is the new lesson. 3.7, switching networks. So, I mean, you can write the title down. I mean, it's in the book. But let me explain why do you get what's in the photograph?
Computer thing?
Yeah, it's a circuit board for a computer.
Board? Yeah.
Yep. Or if you were looking at a really magnified thing, it could be a computer chip. Same concept on a smaller scale. You know what they're called on the internet? They're called logic boards. And guess why? Because the logic I've been teaching you in this chapter, that's what chips know how to do. In other words, they know the rules for AND, for inclusive OR, for exclusive OR, for conditional, for biconditional. All those rules I taught you, chips know how to do. And the reason they know how to do it, of course, what have we been doing all along? Truth tables, right? And what are the only two letters we have in truth tables?
P.
On the bottom of the truth table. T and F, right?
Right.
Just true or false. Well, guess what? Computers only know two things, on or off. Either the power is on or the power is off. And when you put 8 little wires together, you can have different it's just nothing more. So if you just change a true, an on into a true, and an off into a false, it's a perfect match. So computers know logic. In fact, it's exactly the same logic that we've been teaching in this chapter. And the rules are really pretty simple. I didn't say they're easy to remember, but they're simple. Okay, so I am actually going to teach you some wiring here. Okay, now excuse the corny drawing, but up on the left here, this is a battery over here on the left. Over on the right, that's supposed to be a light bulb. And in between is a wire. The idea here is if the light bulb is connected to the battery, the light should go on. Notice the wire is broken in two places?
Yeah.
We call those, that's just a switch. Right now the P switch is off because the power can't jump. And the Q switch is also off. So right now the light bulb would not go on, correct?
Correct.
What would it take for the light bulb to go on?
For us to get that P and that Q connected.
Yeah, how could we get the power there? Wouldn't we have to turn on both switches?
Yep.
Yep. So right now it's off, and when it's in on position, by the way, you don't have to draw it this way, but when it's in the on position, it would just be down here and it would be connected like that. So, what would it take to turn the light bulb on? Only on when both switches are on. Does that sound familiar?
Mm-hmm.
Do you remember only true when both are true?
Yes.
And now I'm telling you only on when both are on? Guess what? There's a reason why those are so similar. They're really identical. So what you see here is a picture. So this, let me get that red out of there. This is a picture of an AND switch. Only on when both are on, only true when both are true. Okay. Now let me show you one more. By the way, I'm only going to show you two. The second one is an inclusive OR switch. Here is the OR switch. Now look at this. You see how switches P and Q are kind of on top of each other this time?
Mm-hmm.
What would it take to turn the light bulb on?
Got to get those down.
Actually, you only need one of them.
Oh, yeah, you could.
See, if you close this one, well, I don't have the right pen. If you close this one, the power would go like this. And we would have success. Wouldn't it also work with only the bottom one?
Mm-hmm.
And now, would it also work if they were both closed, if they were both on?
Yep.
Yep. In fact, it's only off when both are off. Sound familiar? Only false when both are false. You guys, hopefully you're recognizing those words.
Yeah.
Yeah. So you see how electricity works just like the logic I was showing you. It's totally wild. In effect, what you've been learning about, it's logic. You're learning about electrical circuits. So, here, to sum it up, let me put a page in between here. So, what have we learned so far?
Only turns on when both are on, and only is off when both are off.
Okay, yeah, but you got to know which is which. So, for example, when you're doing AND, which is, of course, this symbol, then it's what?
On.
Only on
Both are on.
when both are on. I mean, you don't have to write this down because you have this down when you wrote only true when both are true. Well, here's how that looks. When you have two switches that are side by side like this, that's an AND switch. And you know, you don't have to draw, by the way, notice I didn't draw those in this time. Yeah, well, I'm not going to force you to draw those dotted lines. So you can draw an AND switch like this. And OR looks like this. So when the switches are side by side, like up here, that's an AND switch, and when they're stacked, that's an OR switch. So it's really very simple. Side by side, AND. Stacked, OR. All right, now let's apply this, and you can actually draw logical circuits. let me give you an example. Here, let's do this one. So you know how we work with parentheses first. How do we draw an AND switch? We draw the two switches side by side. Okay, there they are, Q and R, side by side. And then that needs to be what?
Or.
Because it's an OR, that has to be stacked with P. And then we just put a little beginning and an end on it like that. By the way, it would have been perfectly okay if I'd have done it this Q and R side by side because they're an and then P is stacked with that. This would be, these are both correct. So, Q and R are side by side, that means they're ANDed, and then those in turn together are stacked with P because there's an OR right here. So all we're doing is translating OR as a stack and AND as side by side. I'll pause. How's it going?
It's going good.
It's good.
A lot of drawing.
Okay. So let's try and let's do another one here. How about if we do this one on the bottom here? Okay. So let's here's our goal. We want to take this logic statement right here and we want to draw a circuit for it. So we want to do an OR. An OR is a stack, right? So P or R, whoops. Every once in a while this thing does strange things. P or R would look like that, right? A stack.
Mm-hmm.
Q or S would look like this because they're ORed, they're a stack.
Do we not
and
have
then,
ending ones? Oh.
What?
That you just did what I was about to ask, so never mind.
Oh, yeah, I was just getting to the next step. The next step is dog. Good.
Dog study?
Yes. I'm still babysitting for my daughter's dog. My wife, I think, got home. I don't know what's going on. He's probably hearing fireworks, and that upsets him. Anyway, why did I put... All right, I put one stack next to the other, side by side, because of...
Or.
So, and by the way, in the book, if you look in the book, they do one thing a little different than I do. They do this. They put an A here and a B on the end. I don't like that. You need that instead of a light bulb and a battery. I say just leave it like this. So, do you see? Anybody have their book handy?
Yep.
Yeah, they draw a blue A and a blue B on the beginning and the end. Yeah, I would say just leave your drawings look like this. Here, let's do another.
Can I just ask a question so that I...
Oh,
never mind.
absolutely. I'm going to go... Yes.
Just for example, let's say the AND was an OR in the middle of the parentheses. What would it have looked like since they're already on top of or stacked?
Yeah. Well, let me make it here. I'll do it. I'll do that. Let me erase this, and I'll do your question up at the top. Okay.
Okay. Thank you.
So you're saying this.
Yes.
Okay, so we would have started off the same way, P or R. Oh, I guess I should have used blue. Okay, P or R would still be stacked, just like it was before.
Okay.
Now, I'm going to put QS in a different place. They're still stacked, but I'm going to put it down. Why? Because then when I take those two separate stacks, I have to stack them. And this is how I would probably do it, like this.
Oh, okay. Okay.
I actually stacked the stacks. Yeah, that was a good question you asked. By the way, this is Actually, this is also correct for that thing you asked about.
So even though you stack them, you still put the lines at the end. Whether it's and or, you always want to put the lines at the end.
The beginning and the end, that's just showing you the beginning of the circuit and the end of the circuit, like the battery and the light bulb, you know.
Okay,
Like
okay, thank you.
Like back here. Yeah, here I just had the beginning wire with the battery and the ending wire with the light bulb. They do A, B, and I'm saying just put a beginning and an ending. Yeah.
Okay.
So every circuit should have a beginning and an ending like that.
Okay.
By the way, do you see this answer over here?
Yes.
So I like the one on the left a little better because it shows the shows the parentheses.
Mm-hmm.
But this one is also correct over here on the right. Now let's try another. Yeah, I show you this because I want you to see what to do when you do have when you have some negations. We haven't done any negations yet. So I'm going to just grab this and move it up. Okay. So let's draw a circuit for this. All right. So P or not Q. You can either do this or you can use the apostrophe. I don't care. Why did I stack them? Because of the or. Okay? Now, stack that with a Q. No. Somebody driving away, huh? And then we have a not P or Q, which are stacked. And those are stacked with the other stack. So far, all ors, right? Whoop. Hate that when that happens.
So
so far, it's all ors.
If
but
you're
one more yet.
Ron,
What?
if your equation would have an and in it, would you have to shoot one of them off to the side?
You mean like this one over here?
Yeah.
Yeah, I was just going to do that.
Okay.
So yeah, now all of that we did in the brackets, all of that needs to be ANDed with Q. So all of that needs to be side by side with a Q. So basically, yeah, that's correct. And then just put a beginning on. There's our diagram.
We don't have to rewrite them. We just basically connect it with the Q side by side.
Yep. Yeah, you just kind of keep adding onto your drawing, don't you?
Okay.
The only thing you got to plan ahead a little bit is you got to look and say, wait a minute, these are all ORed. Oh, I got to make them all vertical because that's going to be a stack. Oh, and then when I get over here, that's going to be off to the side because it's an AND. So you got to just look ahead a little bit, you know. This really isn't very hard, is it?
Like drawing.
I mean, yeah. And all you got to remember is OR is a stack and AND is side by side. That's it. By the way, there are ways to draw if, then, and by conditional, but we're not going to be learning those. I'm only teaching you these two, AND and inclusive OR. Okay, how we doing? We're probably out of time here. Yeah. So, oh man, everything takes about 1.5 times what it normally takes with this class. It's just kind of interesting. But I am so glad you guys asked questions. That's good. So here's what, at least we got the main part of the lesson done. So what I may have to do is extend this a little bit when we meet on Thursday. Now, I'm going to show you what the assignment was going to be, but you got to hang on because I gotta reduce this because I didn't get everything done in class. So hang on. 3-7. It says 1 through 19. Yeah, we're going to make that because I didn't get through the whole thing 1 through 15. The other 4 we are going to have to get together again before I can explain to you. Okay?
Okay.
Now, wait, there's one more thing we didn't do. We translated from logic to a diagram. Can you go the other way?
Oh, yeah.
So let's just do that real quick. So I'm going to give you a diagram and you change it into a logic statement, okay? So here we go. A, B, okay, what's the logic statement for this? Well, start with the A and the B. What are they? Side by side or stacked?
So they're
Side by side.
They're side by side. So what's the what?
And A and B.
That's correct.
And put
Now,
some brackets around them.
Excellent.
And then or C.
Bingo. Yep. So.
How did you know to put the brackets around them? Just curiosity, because I didn't think of that. Because
aren't the A and the B together in the diagram?
Oh, okay, gotcha.
I mean, is
algebra.
See, here's what's wrong. If we would have left that out, then couldn't that be interpreted as, oh, that's just the B that's stacked with the C? You know what I mean?
Okay.
And then you'd have a wrong drawing. But it's not just the B that's stacked with the C. Oh, it's the A and B together that are stacked with the C. Do you see that now?
Yeah.
Yeah, and you're right. It is algebraic thinking,
Mm-hmm.
Cindy. That's correct. Okay. So of the 1 through 15 odds that I showed you was the assignment. You're going to see some that go both ways. Some of them we're going to give you logic, and you've got to draw the circuit. And then other times, like the ones we just did, I'll give you the circuit, and you have to write the logic. I was going to have you do 17 and 19, but that's going to take some more teaching. So I'll leave that till next time. Okay, don't forget, no tests this week. We're going to be, well, doing questions on this. We'll have the presentation, and we will review. Questions?
No, this is fun.
Well, if you're trying to get me to think positively about you, it's working. Thanks, guys.
Yeah.
Happy 4th of July to you.
Thank you. I'm going fishing now.
Oh, yes, have a good fishing trip.
Yep, I'll see you guys later.
Bye.
Bye.
Thank you.
You are welcome. Thank you.